Hi, folks. Mr. Dell here. We are looking at this is CC2 uh, Section 4.1.1, and specifically looking at scale factor and spending some time on scale factor. This problem set is from the extra parent guide problems that could be assigned, and so I want to use this as the example to reteach scale factor when it comes to similar figures, right? So one of the things in this it talks about determining. It wants us to determine the scale factor, and then it also says these are similar figures. So let me talk about both of those things. First of all, I'm going to look at number one here. Number one is a similar figure. When it says similar figures, that means what you have is the same exact shape and the same same shape, but maybe different size. It's a size different, right? So our shape here, these are both rectangles, but they're different sizes. And then another piece that makes them similar is that their corresponding sides are proportional. Okay, so corresponding sides are proportional. What does proportional mean? Proportional means that the ratio of the sides are equal. So if I say when I talk about ratio of corresponding sides, so corresponding sides would be in this case the same location of the side length on each of the figures. So this being this side here, G to F, is corresponding to C to B because they're both in the same location on their respective figure, right? So what do we have? So you take the new over the original, the copy. So it's always the copy or new. So we could say copy or new over the original. That's how you're going to get the scale factor. And that's also how you compare the ratios. So in this case, copy over new is 3/6, right? So for this figure to this figure, we would say is 3/6. Okay. Excuse me, that side to that side. So that corresponding side, GF to CB, is 3/6. So the question is, and because they're similar, I look and I say, okay, I've got these two. Let's look at EF to AB. EF to AB would be 4/8, right? And because I'm saying they're similar, that means that these are equal, which in fact they are, right? Because 3/6 is 1/2, 4/8 is also 1/2. So corresponding ratios of corresponding sides are equal. That's what makes them similar. So let's go back to what the question was, determine the scale factor. So scale factor is that. That is the scale factor. The scale factor is the ratio of the copy or the new over the original. So we would say, in this case, the scale factor, you could take 3/6. So the scale factor is the copy, 3 over the original 6. In this case, also 4/8. Both of those the same, which, what does it equal? That equals 1/2 is what I said. The simplified version of that ratio is 1/2. So for one, scale factor is equal to 1/2. What else does that tell us? Scale factor also tells us that what happened is this shape, the original, is reduced to 1/2. It's scaled down by 1/2. So each of those sides are scaled to 1/2 because that's 6, that would be 3, that's 8, that would be 4. So this here would be 8, and then this here would be 4, right? Half of 8 is 4. All right, there you go. Actually, I'm going to keep going. I want to show one more example. I want to do number 4 as well, just so to make sure we're good to go. So number 4, similar again, 2 rectangles, right? And so I want to know, what is the scale factor? So looking at number 4, very similar to what we just did for number 1. Scale factor in this case would be to look at the the new to the original, right? Scale factor is always the new over the original. So in this case, we would have the new and the corresponding side is 3 to 9. So 3 over 9. Or you could use these corresponding sides. That corresponding side 4 to 12, right? The new is 4, the 12 is the original. So it's also equal to 4 over 12, right? Which, if you simplify each of these, they both equal 1/3. So my scale factor for number 4 is 1/3. There we go.